Okay, so hello everybody. My name is Michał Rokita and I'm going to talk about using FFmpeg from Python in a way that doesn't hurt yourself. So yeah, about me shortly, I'm a Python developer. I work in Python for 6 years now. I'm still a master's student at Warsaw University of Technology in Computer Science. And I am also a devout beach volleyball player. As you can see, you can also play beach volley indoors. This photo was taken like last week or something like this in Spawa, so yeah, a very cool place to play beach volley. I also play guitar. This is me going to PyCon Czech Republic this year on a train. And I also, my second sport is this kind of thing. I rarely do it nowadays because I found it dangerous as I grew up. So yeah, like it's pretty scary sometimes, but I still have fun. Okay, so enough about me. So yeah, the agenda of this talk. First, I'm going to talk what FFmpeg is exactly. Then we are going to go through some simple tasks using the FFmpeg CLI. Then we are going to do a bit more complex stream processing with the FFmpeg CLI again. Then to make it easier, we are going to switch to FFmpeg Python and like do the same thing in a more readable and maintainable way. And then, as a more complicated thing that you can do with FFmpeg Python, we are going to incorporate processing of individual frames in Python by incorporating OpenCV and Python's CV2 module. And I will briefly talk about how to test things you develop with FFmpeg Python and FFmpeg. So, what is FFmpeg exactly? It is a versatile tool for multimedia processing. The FFmpeg name stands for Fast Forward Motion Picture Experts Group. And, well, it says motion picture, right? But FFmpeg can also process subtitles, it can process audio files, probably all the video and audio and subtitle formats you know. And it's a great thing. I think it's the only open source tool that gives you support for probably any video file that somebody can come up with. And it's used internally by Google Chrome, Audacity, Blender, OBS, and so on. Even like in a small tool called YouTube DL, you probably know, like if you wanted to download a YouTube video, you have a Python package called YouTube DL. And it was built, the project was started in 2000 by Fabrice Bellard. So, let's get started. So, let's say you have a video file and you want to trim it, and you have FFmpeg installed. It's enough to do this simple call, in which probably hide banner is redundant, but it's nice because you don't have this banner which FFmpeg prints that tells you what features it was compiled with and stuff like that. So you probably not need this. You have the I flag, which stands for input file, and yeah, we have video MP4. And then you tell it to seek to the 30th second of the file, and then you tell it that it should take the first 10 seconds of the stream you have. So it takes seconds from 30 to 40. And then this Y flag tells it that if the output file video trim already exists, it should overwrite it without asking you. And yeah, the output file is video trim. So this is how simple it is if you have a video file and you want to trim it using FFmpeg. Yeah, like it's very simple. It's much simpler than running some video processing software on Linux, at least for me. So let's do something a bit more complex, still in raw FFmpeg using the CLI. Let's detect some edges. So to avoid, like copyright issues after this gets published on YouTube, I used my own dashcam footage. And we have this original video, like with cars moving and stuff like that. So to detect edges in any video you have, you can just Sorry, I think I have lost focus. Give me a second to move the mouse left, right. Yeah. Okay. Yeah. Again, we run the FFmpeg command. Again, hide banner. Then input, the same thing. And then we have this thing which stands for video filter. And we use the FFmpeg's filter edge detect that is built in. It uses Kani's edge detection algorithm, and we tell it like some parameters like low and high threshold, and the output file. And we run it. It does some processing. It tells us like the progress in various ways, the duration and the frame number, and this is what we get afterwards. So yeah, like it's quite simple, but it's a very, very powerful tool. Like you can do complex filter graphs, which we are going to talk about in a second. So another tool which FFmpeg comes with is FFprobe. It's very useful if you have a video file and you want to probe it. For example, to know like what codec it is using, what is the duration of the file, what subtitle streams it has, what audio streams it has. So the output of this command, you just can provide it with one video file or many, whichever you want. So the output is, the first row is like, the input file number 0, the format of the file, which is the MPEG-4 family, and then you have some metadata, including the encoder, which can be quite useful for like getting to know how a video was created. And then you have duration and bitrate information, and then you have a stream. In this the case of this video file, this video stream is Japanese, hence this JPN thing in the next to the stream index. And then you know that the video codec is H.264, and you have all kinds of information, and here you have the audio stream. So yeah, and how to do a bit more complex filtering using FFmpeg. A short disclaimer, FFmpeg itself, its CLI, is not very good for writing complex stuff, because it's a CLI, it's going to get hard to maintain, and the commands you have to write with complexity, they become harder and harder to read, which is a bad thing. So we are going to go for an example. We'll generate an RGB color histogram from the source video. Then we are going to run edge detection on the same source video, and then we are going to merge all the 3 streams produced, I mean like 3 including the original stream, and place the results of the above on top of the source video as an overlay. So we basically have a picture-in-picture thing created by processing the original file. So don't get scared, like this is how the FFmpeg call looks right now. And yeah, like this is hard to read. I don't expect you to understand this right now completely. But the important part is that you can see there is this filter complex argument, filter complex flag, and you pass the processing pipeline here, like you define a signal graph using this string here. And, well, the vertices of the graph are described by semicolon separated parts of the string. And let's quickly go through the first line here. You have this format, GBRP and histogram things. These are filters. So first, we filter the video file. On the left, we have the source node, which is 0, which means this input file. We first change the format of the video file to GBRP to get like the RGB channels in a raw form, and then we filter it to generate a histogram of these channels. And we save this as a hist node, and this is probably a more readable description of, like, this is the equivalent of the string we have there. So we have our source video it's marked as the stream number 0. Then the first line is, we first format it as RGB and generate the histogram, save this as a hist node, then we scale this hist node to increase its width by 2, like you see this like initial width times 2 colon IH. This basically resizes the stream. We save it as hist scaled, and here we merge it with using the overlay filter of the hist over, like we save this overlay as the hist over node, and the argument first of this overlay filter, this is this part of the description. Here, like you have this original video file as 0, which is the base video, and the stream we are going to overlay on top is hist scaled. So we basically merge this using an overlay, and we do the same thing with edge detection here. We also scale it, but this time so we want to reduce the size because edge detection has the size of the original video. If we put the original video with edge detection on top of the original video, we'd see just the new video, so what's the point? And the output of this is something like that. And like this description using FFmpeg CLI is quite complex and pretty hard to read, at least for me. So we probably want to make it less complex. But like it works. We have the edge detected video, we have the histogram for the red, green, and blue channels. And like the output, like you could put any stream, like for example, if you wanted to put somebody's face here, like when you have presentations and stuff, it's a pretty common thing to do. So how to make this easier and like mostly easier to maintain? There is a very nice binding for FFmpeg for Python, which is called FFmpeg Python, simply. And like this is the GitHub repo for the project. It is very convenient and very easy to use. What it does is it generates FFmpeg command line arguments from your Python code. So it is very easy to design something complex and make it like like you can swap things in there. It's not like a large string that you have to edit. It's like you have to change one variable to, for example, change the filter you use. And it provides helper functions for running FFmpeg in a subprocess, and it includes a FFmpeg probe function, which allows you to simply read all the stuff FFmpeg probe reads as a plain Python dict, so you can easily process it and make decisions in your software based on what you have in the probe results. So, how to do the very same thing we did with FFmpeg CLI in Python. First, we import the FFmpeg module. Then we declare that our input video will be this VIFO PH MP4 file. Then we build our histogram stream definition here. First, we tell that the source is the input video, then we filter it with the format filter and change it to RGB channels. Then we filter it with a histogram filter to generate the histogram. And here we have the display mode stack argument to make it a stacked histogram. And then we do a filter scale to just increase the width of the printed histogram. Then we do another. As you can see, we can treat these things independently now, right? First, we have the histogram, which we could basically, if we wanted to, we could save in a video file of its own now. And then we have the edges stream we generate with the edge detect algorithm, and we again scale it to reduce its width. And then to do an overlay, we can do a thing like this. We just tell FFmpeg Python that we want to overlay the hist stream we created here on line number 4 onto the input video which we created in line number 3. And again, we do another overlay on top of the overlay we've done with the hist and the original stream. We add the edges stream here, and we tell it that we want it on x-axis of 800 and y of 0. And we can just run the whole pipeline using this short function call. And this is the generated FFmpeg call. It's very similar to what we've done manually in FFmpeg CLI. The only difference which is significant is that it has this end of file action repeat, which isn't necessary because we generate all the streams from one video file and they have the same duration. So we don't have to repeat something if it's not long enough. So yeah, I think this definition is much more human readable than this thing, which when you look at it for the first time is just like crazy. And you have the same result. So another cool thing you can do with FFmpeg and Python, as I told you before, is processing raw frames with Python code. So we have another video, and we are going to detect the registration plates of the cars passing by. In order to achieve this, we need to, I mean, it's probably, there's a lot of ways to do this, but like, the way I'm going to present you is with 3 logical components. So let me zoom in a bit. Oh no, this is function, not control. Okay, so we are going to have 2 FFmpeg processes. This is the first of them. And the first FFmpeg process is going to be responsible for decoding video frames from our original file and decompressing them, because usually you have some kinds of compression in video files. And then after decoding these frames, we are going to read the standard output from Python and dump it as a NumPy array of, you know, like of the image, like just, you know, all the RGB channels, and just as an array of numbers, we can read this FFmpeg output. And we are going to use OpenCV and the Cascade classifier to detect the registration plates. And we are going to use very simple OpenCV functions to mark the registration plates. And after we have this, and we have, you know, OpenCV images we can dump into our output stream, we are going to exactly do this and just pass the raw frames to a second FFmpeg process, which will re-encode these frames into a new video with our registration plates marked. So, oh, I forgot to undo the zoom. Yep. So again, we just import stuff we need: FFmpeg, NumPy to read the arrays, and CV2. We define our input and output files. This function I am not going to discuss in detail. It basically takes 2 arguments. The first one is the frame we got from the input stream, and the second is a list of coordinates for the found registration plates on the corresponding frame. So basically, this part marks does all the things related to marking these plates on the frame. And this is plain OpenCV stuff. I am going to, I have shared this presentation, the slideshow, and all the examples on GitHub. So if you want to run it by yourself, feel very welcome. And this part is responsible for retrieving the information we need from the input stream using the FFmpeg probe function you have here. So this little trick with the next call allows us to skip a for loop and an if. So basically we find the first video stream in the file, and we retrieve the width, the height, and the frame rate of this video stream, and we store it as these variables. And this will be useful later on. So this is the declaration of our first FFmpeg process. We say that, yeah, like the input file here will be our input. We take only the video from the input file. We first apply the frames per second filter. This part is useful if you wanted to skip some frames to make the processing faster. You could reduce the frame rate here, and FFmpeg would just take some frames, yeah, like to reduce the frame rate, right? For example, you have 30 frames per second. You want to take 5. Yeah, like it will be less accurate, but the processing will be shorter, and you'll get probably the same results most times, like if the movement isn't too quick. And then we say, we tell FFmpeg to output this stuff it generates to pipe, and we wanted to re-encode it as raw video, so it just prints the raw video frames as bytes. And we tell it that we want the pixel format BGR24, which is blue, green, red, 24 bits, which is the format OpenCV natively uses. And we want to run it in the background using the run async, and we want to pipe std out, because we declared the pipe here, to read this data into Python. And the second process, that's basically the same thing, but in reverse. It accepts the raw video. We define the input here. We want to reduce the frame rate of the output video to make it a bit slow motion, like 4 times slower. And then we declare the output file with the standard pixel format UV420p, and we tell it that overwriting output is okay, and we again run it as async, but this time we pipe standard input, not output, because here we will write our frames generated in Python. And here we have a OpenCV cascade classifier definition, which is just a very simple built into OpenCV classifier. This XML you just get from OpenCV's repository. It has a classifier for license plates. And this is the most important part. We can iterate over the frames, the bytes that FFmpeg outputs, the process 1 outputs. We know the video width and height because we probed it. We multiply it by 3 because we know the video has 3 channels for R, G, and B. And then we convert this to a NumPy array as in frame by doing this reshape trick. Because yeah, like we want to reshape it. We have 3 channels. We know the height, we know the width, and we convert it to 8-bit integers. And then we copy this frame. I don't think this is actually necessary, but I'm not sure. But it's safer to copy because OpenCV by default mutates the frame you pass to it. So yeah. And here we use the classifier to find our plates. It accepts the frame as an argument. You have here some parameters which you can use to adjust the way it detects those plates. And then we mark the plates using our mark plates function declared before. And after we mark the plates, we write the frame back to the process 2. So it can re-encode our video stream. And to clean things up, we close the standard input after we have finished writing to process number 2, and we wait for the processes to quit. This is the result of this script in Python. The classifier isn't like perfect, but as you can see, when this Passat comes by, it can detect its plate. And when you see another car, it also can detect the plate. But the point is, you can do this with FFmpeg and Python, and it is fairly simple. So, yeah. And what about testing things you develop with FFmpeg and Python? It's a complex thing, because sometimes you might have to process the stream you generate frame by frame, because these are your requirements. But for simple stuff, using FFmpeg probe to just make sure that your output is sane and, for example, is within the desired duration you expect can be enough. You can also use the FFmpeg compile function from FFmpeg Python to retrieve the generated FFmpeg command. So, for example, if you do some stuff in FFmpeg Python which generates this command dynamically, it might be very useful to make sure that it contains all the bits that you need. And a very useful thing which I found out a few years ago is that the FFmpeg maintainers provide a diverse library of video and audio, I think, to samples at fatesuite.ffmpeg.org. You have like all kinds of videos in all kinds of codecs, formats and stuff. So if you develop a tool which has to accept every format possible, it is a great library to incorporate for your testing. So yeah, conclusions. It is a very powerful and complex tool. It has a lot of options. If you run FFmpeg H full, it's overwhelming what it has. But it is also quite simple to get started to using it. If you are using it for complex processing, as you probably saw a while ago, it's much better to use a binding like FFmpeg Python. Oh, sorry, I think this is in Polish. Yeah, I have not noticed this. So basic operations are, you can cut videos, you can convert subtitles, you can compress your videos, you can even compress your audio files. You can even use FFmpeg for streaming. It supports SDP and RTMP. I've done some stuff incorporating FFmpeg and UDP multicast video streaming, and it worked pretty well. So yeah, this is it. I have 2 bonus slides, but we'll see what happens during the time for questions. These are the links for the GitHub repo, which includes all the examples here, and the video files are used for them. So feel free to run these at home and see for yourself. Just play around with parameters, and the slideshow is available on the GitHub pages too. So yeah, thank you very much.
Thank you very much. All right, guys, please raise your hand who has some question to our guest. I see one behind. Just a sec.
Hello, thanks for the presentation. It was really great. And my question is, how hard would it be to run on board of your car in real time, so you can detect whether someone is following you and what is the plate number?
So yeah, so you want to do this in real time, and here I would say that for real time stuff, I'm not sure if using FFmpeg is the greatest idea. I mean, you can still do this. You still can use the if you want to do something very efficient, you can also use, I think the library is called PyWaw or something like this. And this is a different level of binding with FFmpeg, because you bind with the C stuff that lies underneath. But I mean, like, I probably would just use OpenCV for this, and like pass the registration plates, because this is fairly efficient, and even Raspberry Pi can simply get a video stream from its onboard camera to just pass it to OpenCV. FFmpeg is mostly useful when you either have a video stream which you receive from somewhere else. For example, you have like some online television, and you want to do stuff on it in real time, then FFmpeg might be actually quite useful, because you have to decompress the whole stream, and this is the main issue in these kind of things. But for real-time processing, I would be very careful with using FFmpeg for, at least for just decoding the stuff, because usually you can get it in raw format without encoding and decoding again.
Yeah, thanks a lot.
Anyone else?
What kind of projects you used in this FFmpeg?
Could you please rephrase? You mean what kind of projects I've done in production using FFmpeg?
Yeah.
Well, I used FFmpeg for multiple things. I used to use it for writing simple, not really too simple, but video downloaders from various sites not supported by YouTube DL, and it works fairly well for this kind of thing too. I used it for accepting all kinds of video files in one project to generate, to process these files and generate them, encode them in a way that all the files have the same parameters, like bitrate and stuff. So basically a user can upload a video, and then it's very easy to play it back on the devices I need to play it on. So this is another kind of thing I used FFmpeg for. I use FFmpeg a lot when I have to trim simple video files. Even for this talk, I used FFmpeg to make this initial trim for the dashcam videos I had on my laptop, because they were like 2 minutes long, so it would be too long for this talk.
So you basically can make your own video editor using this application.
Yeah, I mean not exactly editor, but yeah, I used it to make it accept any kind of video stream, including GIFs, and make it generate consistently videos of the same parameters, including resolution. Yeah, like to make the original stream fit the desired display size and stuff like that. I also used it for re-encoding subtitles, because yeah, like one time I wanted to watch some movie and subtitles were available in some weird format which nobody uses, and my player didn't support them too well, so I wanted to re-encode subtitles. I think it was from VTT to SRT or something like this, and FFmpeg does re-encoding of subtitles too.
Okay, thanks.
There's one more.
Is it possible to recognize other objects than registrations plates?
Yes, I mean this is more related to OpenCV, and a short disclaimer: I do not work in like the image processing business. It's mostly I'm a web developer, so I look from this perspective. But yeah, like you have HAR cascades on the OpenCV repository for faces, for eyes, and there are also some tutorials on how to train your own HAR cascade that you can use in the very same code I provided you. So you just use some tools to, you have a data set, you use OpenCV to generate an XML file which extracts like the features of the data set, and then you can basically classify whatever you want. So yeah, it's a cool thing.
Okay, thank you.
All right, thank you very much. It was a great speech. Let us know after the, just in the set, like which question was your favorite, and this person will obtain a code for JetBrains. And please give a big thank you to Michał for this great speech. And
thank you very much.
I encourage you to buy a beer, stay with us a little bit longer, just discuss Python-related things. Thank you for being here today, and see you next time next year.